My name is Dr. Bbosa Science. Today, 31st May 2019, we are going to consider reactions of amines. 1. Primary and secondary amines react with acid halides to form amides. For example, ethanoyl chloride plus methylamine will give you methylethanamide. Mechanism: this one uses the lone pair of electron to attack the ethanoyl chloride. The positive will come here, electrons come back there, this bond breaks off. We subtract HCl, one hydrogen from here, and a chloride ion. Then we get methylethanamide. 2. Primary amines undergo condensation reaction with carbonyl compounds in the presence of an acid. For example, ethane condenses with methylamide to form an amide. Mechanism: the lone pair on oxygen atom picks a proton. You get then the amine uses a pair of electrons to attack the carbonyl carbon. This double one bond breaks. A positive charge goes there. There's a proton shift. The proton jumps from this nitrogen to this oxygen. Nitrogen uses the lone pair to form a double bond. This bond breaks off. Then you lose a proton to form an amine. Example 2. Propanone plus acyl amine in presence of an acid. You can pause, complete, and then compare your answer with mine. I hope you have got mechanism. This one picks a proton. You get a protonated oxygen. Then acyl amine uses a lone pair on the nitrogen atom to attack the carbonyl carbon. Then this bond goes. This bond will go. Then we shall form then there is a proton shift. A proton jumps from this nitrogen atom to this oxygen atom to form then this one uses a lone pair of electrons to form a double bond there. This bond breaks off. Then you get then there's a loss of a proton. Again you get your product. This question is very common, so endeavor to learn this mechanism. Try it over and over until you master it. Notice the movement of the positive charge from hydrogen atom to this oxygen atom to this nitrogen atom to this oxygen atom to this nitrogen atom until you subtract it. So you cannot lose a positive charge until you have subtracted it from the molecule, or you have neutralized it from the molecule. As example will be ethanol plus phenyl hydrazine. All compounds containing a nitrogen with two hydrogen atoms can condense with carbonyl compounds. So you can pause, complete, and then write the mechanism. I hope you have got that one. Then the mechanism remains the same. First, a carbonyl compound abstracts a proton.
The Science Foundation College e Namave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
From the solution, then you will get then the phenyl hydrazine will use alone pair electron. This nitrogen atom is 2 hydrogen atoms to attack the carbonyl carbon. There's the proton shift. This hydrogen atom jumps up there. We get then this nitrogen uses a lone pair to form a double bond. This bond go. Then we get that one. Three, formation of amines. Primary and secondary amines react with alkyl halides to form amines. For example, ethyl chloride reacts with methyl amine to form methyl ethyl amine. Then mechanism, this being primary alkyl halide, then there is a loss of a proton to form an amine. To form an amine. The mechanism is described as SN2, which is substitution nucleophilic nucleophilic, bimolecular. Primary alkyl halides undergo SN2 substitution, nucleophilic, biomolecular. The slow step involves two molecules, the alkyl halide and the amine. Example 2 chloro, 2-methyl propane reacts with methyl amine to form an amine then the mechanism this being a tertiary amine first loses the chloride ion. Then you get the amine uses a lone pair of electron to attack a carbonium ion. Then we get with a positive there, then loss of a proton produces an amine. Get that one. 4. Distinguishing between classes of amines. The reagent is sodium nitrate in HCl at a temperature less than 5 degrees. The observation is that primary amines produce effervescence. For example, methylamine plus sodium nitrate plus HCl will give us methyl chloride plus sodium chloride plus nitrogen gas, which produces effervescence, plus water. Secondary amines produce yellow precipitates. For example, dimethylamine plus sodium nitrate plus HCl, you get a yellow PPT of a nitrosyl compound plus water plus sodium chloride. 3 aromatic amines and tertiary amine give no observable change. For example, phenylamine reacts with sodium nitrate and HCl to form benzene diazonium chloride plus sodium chloride plus water. Similarly, trimethylamine reacts with sodium nitrate plus HCl to form methyl chloride plus sodium chloride plus methyl diazonium chloride. Remember, the reagent is sodium nitrate, not sodium nitrate. Secondly, the temperature must be below 5. At the temperature above 5, all the 3 classes of amine will give the same observation is. Example, give one reagent that can be used to distinguish between the following compounds from each other. The compounds are phenylmethylamine, then this one and that one. The reagent is sodium nitrite, not sodium nitrate, in the presence of HCl at a temperature less than 5 degrees. If the temperature is above 5 degrees, then you cannot distinguish this compound. So if you don't put the temperature, then you are not going to get any marks. Notice that this is a secondary amine, and we say that secondary amine is, will give you yellow PPT. Also notice that this is a primary amine because the nitrogen has got 2 hydrogen atoms. So primary amines give effervescence. So you will have this one will give you effervescence. Then this one is the tertiary amine. Tertiary amine will give you no observable change. Will give no observable change. Omutima kwe guteeterera, azalibwa bakungu, yakuzibwa bulungi, atambula bulungi, oba kiriba kitya ng'ono nsuula naye, nga tulya naye, oba muyaga gutya oba buzibu butya, ono tufa naye. Ono yabasinga, yono yeye omutima kwe guteeterera, obulamu kwe butambulira, oba butiti butya oba kwaka gutya, ono ndifa naye. Era ndiba naye, mubalungi gwe nnonze, mubalungi gwe nfiira, mubalagavu mulungi.